Today I'm looking at this Accumate battery charger. I've had this for quite a few years and it's served me well. I would say it's a semi-automatic charger. It describes it as automatic charger for lead acid batteries, and what it can cleverly do is not only detect whether a battery is in good order or whether a battery is faulty, and it will illuminate a light to tell you if it's a faulty battery, but it also controls the amount of charge that it puts into the battery. So the lower the charge in the battery, the higher the demand, the higher the charge it will provide. It can also maintain the battery. Once the battery gets full or virtually full, it will provide a gentle trickle charge just to keep the battery maintained. So if you're, say, got a motorbike that you're holding in storage over the winter, you can connect this up to it and it will give it a nice gentle trickle charge to keep the battery topped up while the bike's not in use. One of the common faults with many electrical devices, plug-in devices like this, is these little rubber protectors, wire protectors they put on. These are to protect the wire from becoming damaged at the point where it enters the body. Because it's quite a sharp cut-off, the wire tends to get a very sharp bend there, which can damage the wire. These devices are designed to flex so that the wire doesn't get so badly damaged. The trouble is that sometimes either these harden over time with age and therefore become very stiff themselves, or they're made out of quite a robust plastic which is actually quite stiff to start with, which I believe is the case here, because this is quite stiff. The wire has been flexing at the end there, and as you can see, it has actually cracked the outer sleeve, and I'm afraid the two wires did actually touch each other the other day and have shorted this device out. Now, whether it's permanently damaged this or not, or whether it has safety cutouts within it, I don't know. Anyway, my thinking is, as usual, that the device is pretty useless as it is. I can try and effect a repair. If it doesn't work, I'm no worse off than I was. If it does work, I could save myself the cost of a replacement. This is the mains plug, and the main side of this is actually in good order. Just have a quick check there just to make sure. Yep, there's no evidence there of any perishing or cracking, so that's in good order. That can stay as it is. It is actually the charging side, which is the lower voltage side, which is damaged. Right, 4 screws at the bottom here. Hopefully this will be very easy to open up. I don't know whether the interior is connected to the bottom or the top, or whether it's not connected to either. I'll try and lift it away from this side and we'll see. See whether the internal gubbins lifts away with it, or whether they stay in the top half. Right, that's 4 screws away. Gently lift it apart if we can. Now it feels straight away, yeah, all the workings are in the bottom half. That's the cover off and away. A little bit of dirt over the voltage control switch there. A little bit of try that again. A little bit of corrosion on the power adapter. I can see no evidence in here of burning or damage. There's no obvious signs of any reset switch. Let's pull the protector out. I'm going to cut this off here, and what I could do is use an electrical block connector, a domestic block connector, cut those ends off there, cut that end off there, strip those back, strip this back a little bit, and use the block connector, keep the block connector on the other side, and then I would be able to pass this through this protector into the block connector. I haven't got any proper cable snips. I've got this little pair of snips here. I think these are really for gardens, for bushes. Hopefully they will be able to snip the wires here. I've got to watch I don't cut into anything else. That worked. There we go, that's the wires free. That's then cut from there. They definitely look moulded in. Trying to pull the wires out, the coppers out, so it leaves me a hole I can drill into. There we go. There is some copper wire left in there. But now I want to take this into the garage. I'm going to I can just pop that in the vise. We'll run a drill through it and hopefully make enough space for these covered wires to go through. I think I can snip these off level. There we go, that's waste, don't need that anymore. Separate those a little bit, might make them easier to push through once I've got that sorted. Right, I'm not going to film this next bit, I'll show it to you once I get it back. We've now brought this back from the garage, we've drilled holes through it, got rid of the old wires. It was a lot more difficult than I thought because, well, being rubber, when I try and grip it, it squashes it. If I don't grip it hard enough, then the drill tries to turn it. So it did take a little while to do, but I have got it done, and hopefully now I can feed these cables through it. Make sure I'm putting it on the right way round, of course. Right, I've managed to get it through, I managed to force it on. That is now ready to fit into there, I hope. Yes. So my next problem, yeah, that goes into there, okay. My next problem is to separate these wires. Bend them over a bit, try and straighten them out. Now I want to separate the two wires from each other, and I need to strip them back a bit. Okay, I want to cut these two wires apart. I'm not quite sure the best way to do this actually. It works quite well. I'm very frightened of cutting my fingers, I have to say. Oh, don't damage that, please. Ah, there we go. That's them separated. Super duper. Right. Next thing, having separated them, already got these separated. I just had a silly thought there. These have got a positive and a negative to them. How do I know which is which? That's an important point. That is an important point. I need to know which is positive and which is negative. Yes. My friends, I think I may have messed up here. Because if I don't know which is positive and which is negative, how am I going to connect these properly? It is important. And I think I've just found a way. On the bottom of this circuit board, it does give it as a B plus and a B minus. So I'm going to assume that this is the minus and this is the plus. I then have to follow this up to the red and the black. Red being positive, black being negative. I need to make sure that that's making a good connection as well, but I can check that in a few moments. Right. We have the red on the upper level here. That's the upper. Trace it all the way down, it becomes the lower, the lower, the lower, the lower. Swaps back to the upper, the upper, the upper, and that is the positive. And that is the negative. So if we bend the positive over, and that is the positive, the next thing is to try and strip these wires back. It's very annoying that they keep bending back the way. I don't really want them bent that direction. But what I do want is the outer sheath stripped off them. Now, not going to be so easy. Hold on to the wire because I don't want to pull the wire out of the better. Pull the wire out of the circuit board. Okay, we now have the outer sheath stripped. Twist the ends of the wire off. So I will put these on this side, close that down, hopefully to clamp onto that earth wire. That looks good. And for the positive, we'll put the negative in here, so I need to open up these two again. Make sure they're opening off. A couple of turns more. That looks good. Put the negative into there and tighten that up. Make sure the positive's twisted off. And tighten that off. Make sure all four are tight. Okay. Now we'll bend that over that way. We can then pull this along as far as we like to put it onto there. Yeah, and we will call that appropriately done. I hope, anyway. And this is just to ensure, again, that I have got these connected up the right way. I'll use my multimeter, if I can open it. We want it on a continuity check. Positive to positive. I'll turn that around so that the camera can see it too. Positive to positive. Low resistance. Positive to negative. High resistance. Negative to negative. That's slightly worrying because we have a high resistance. We've got a good connection on the positive, but we've got no connection on the negative. Now what I suspect that is there's a problem with this here, this connector here. Positive is uppermost, negative is lowermost. Let's have a look at the lowermost. Right, it appears that, again, I've no idea if you can see that or not, but it does appear that that has opened up wide. I'm going to use perhaps the probe to try and tighten it up a bit, although it is possible that the actual connector itself has burnt out. And that felt like it forced into place. Negative to negative. We now have negative to negative, negative to negative, 0 across the positive, open circuit, and where did I put it? Where's it gone? It's hiding out of sight here. Start getting these things into knots. Positive to positive. Superb. Definitely no cross. Excellent. Okay, we seem to have positive to positive, negative to negative. We seem to be all connected up. The only thing left to do in that case is to put the cover back on, make sure all these little eyelets go into their right places, that they connect into the right little slots on the lid. Then I need to get a battery, and we shall check if it will charge a battery. We're back out into the garage. I've hooked it up to this battery, this 12 volt motorcycle battery. This battery could actually do with a bit of topping up. The water levels are a little bit low, but nevertheless it will do for this practice. Now what I'm looking for is, when I switch it on, I'm looking for a power light at the 12 volt. I'm looking for a charging light. Let's find out. Let's see if it will work. Now there's no on-off switch, it's just plug and play. And there we are. Straight away I've got the amber light showing me that it's charging. I've got the red light showing me that it's charging at 12 volts. She's connected up, positive and negative, and it seems to be working. I'm going to leave that like that for a little while. We'll see if it fully charged. When it's fully charged, as I say, I should get a green light here indicating that it is fully charged. Well, here we are the next day. Obviously the green light is now showing that the battery is fully charged. It does appear to be fully working. There's no risks of any other damage to the wiring, at least I hope so. No, everything looks fine. So the only thing I have to do now is check the battery itself to make sure the battery has actually charged. Okay, let's switch this off. Again, there's no switch, I can only unplug it to switch it off. Disconnect it. Put it onto volts, DC. Select the range up to 20 volts. Make sure I get the connections the right way round. And it's actually holding at around 13.8 volts. And that looks pretty steady to me. I'm confident that that battery charger has worked and that this battery is charged. Excellent. I hope that's of help to some of you out there who have suffered from these problems where cables break near the entrance, but I'm quite pleased to say that has worked, and hopefully I'll be able to use it for many more years to come. Thank you very much for watching.